looking at matrices today. By definition, a matrix is an array of numbers, or it's an arrangement of numbers into rows and columns. Alright, so it's an arrangement of numbers into rows and columns. Another definition could be that a matrix is a simple mathematical structure that holds numerical information in rectangular form, usually enclosed in a bracket. You know what a rectangle is? A shape that looks like this. Now, when information is held in something like this in a rectangular form, we could put 2, 4, 3, 5, and then this is closed by a bracket. This is what we call a matrix. For example, if we say a college has its number of students in each of the higher classes to be grade level, grade 10, we have grade 11 and grade 12. And in grade 10 we have 14 students for male and 8 students that are female, 6 male for grade 11, 12 that are female, and 21 male and 18 female. So this is male, female. If we are to represent this in a matrix form, we will put something like this, and then 14, 8, 6, 12, 21, 18. And so a matrix is a simple mathematical structure that holds numerical information. Discover that everything within these brackets is a number, and this is more like a rectangle. All right, so today we are just looking at the basics of matrices. We're looking at addition of matrices, two matrices together, subtracting one matrix from another, multiplying a matrix by another matrix, and other things. So first of all, let's look at the addition of matrices. For, let's say, let A be the matrix 3, 8, 4, 6. Let the matrix B be equals 4, 0, 1, minus 9. Now, the addition of these two matrices is the same thing as A plus B. And A plus B would be 3, 8, 4, 6, which is the matrix A, plus the matrix B, 4, 0, 1, minus 9. And when you are adding up, you add up this number 3 to 4, you add up 8 to 0, you add 4 and 1, and then you add 6 and minus 9. So what we have is 3 plus 4, 8 plus 0, 4 plus 1, 6 plus minus 9. Alright, so this will be equal to 3 plus 4, which is 7, 8 plus 0, which is 8, 4 plus 1, which is 5, and 6. Now, when we have plus minus, it's the same thing as multiplying plus with minus, and they are going to result in negative minus. So what we have here is 6 minus 9, which is minus 3. So this is basically how we add up two matrices together. They have the same dimension. Please take note, when we have this matrix A is 3, 8, 4, and 6. Same with matrix B being 4, 0, 1, and minus. Now, to look at the dimension, this matrix is a matrix that has two rows. This is the first row and this is the second row, and it also has two columns. This is what we call a 2 by 2. That you do it like that, we spell it 2 by 2 matrix. Okay, row by column. The row is 2, the column is 2, then it's a 2 by 2 matrix. This is for addition of matrices. Now let's look at subtraction of matrices. When we subtract a matrix from another, let's say let M, the matrix M, be 3, 6, 7, 4. N be the matrix 2, 5, 1, 2. Now, if we say subtract the matrix N from the matrix M, we'll be having M minus N, which is just the opposite of addition. That will be 3 minus 2 is 3 minus 2 is 6 minus 5. Also have 7 minus 1 and 4 minus 2. This is going to give us 3 minus 2, which is 1, 6 minus 5, which is 1, 7 minus 1, which is 6, and 4 minus 2, which is 2. So, we discover that when we add up matrices, you see that this is also a 2 by 2 matrix, the matrix M. Matrix N is also a 2 by 2 matrix. So the dimensions have to be the same. If you have a 2 by 2 matrix for M, and N is a 2 by 3 matrix, you cannot add them up. So let us look at what a 2 by 2 matrix looks like, a 3 by 3 matrix, and other dimensions. Now, this matrix 2, 1, 3, 2, 4, 6 is quite different from what we've been looking at. How many rows do we have? This is first row, second row, and third row. So we have 3 rows. We also have 2 columns. So this is what we call a 3 by 2, a 3 by 2 matrix. All right. If we also have 2, 1, 2, 3, 2, 5, 4, 1, 6, we have 1, 2, 3, 3 rows. Also have 1, 2, 3 column. This is what we call a 3 by 3 matrix. Okay, this is what we call a 3 by 3 matrix. Same number of rows, same number of columns. Let's look at what a 2 by 3 matrix will look like. A 2 by 3 matrix will be 2, 1, 4, 3, 2, 8. Now, we have 2 rows, or we have 3 columns. So this is what we call a 2 by 3 matrix, a 2 row by 3 column matrix. So there are 4 by 4 matrices, 3 by 4 matrices, and others. Now, as I said before, the dimension must be equal if you are going to do addition and subtraction. So if you are adding, it must be, let's say, 2 by 2 matrix multiplying or adding up with a 2 by 2 matrix. If you are also doing 3 by 3, the both of them must be 3 by 3. Let's say you are subtracting a 3 by 3 matrix from another 3 by 3 matrix. So we cannot do 2 by 3 matrix subtracting 2 by 2 matrices. So the dimension must be the same. Lastly, I'm going to look at multiplying one matrix by another. Multiplying a matrix by another. Say we have we've used A, B, we've used M and N. Let's use P and Q. So let's say let the matrix P be let's use a 2 by 2 matrix. Or now let me do something different. Let's use a 2 by 3 matrix. All right, so 2, 1, 4, and then 3, 1, 2. This is a 2 by 3 matrix, right? And let the other matrix Q be a 3 by 2 matrix. So this will be 1, 2, 4, 1, 3, 2. This is a 3 by 2 matrix. Now, when you are multiplying, is a 2 by 3 multiplying a 3 by 2. Now, take note, the end number here and the next number that is starting the next matrix must be the same. All right, and then the number here at the beginning must be the same with the number at the other end. So it looks like you are going to multiply a 2 by 3 matrix by 3 by 2 matrix, you are going to get a 2 by 2 matrix at the end of the day. So it's like we are cancelling this out to produce a 2 by 2 matrix. So let's solve. When we say P times Q is equal to, now when we are multiplying, you're going to multiply this side, the first, you multiply the first row at the first column, and also you add up everything, then multiply that same first row by the second column. You add up everything. You also do the same for the bottom. So we'll be having 2 times 1 plus 1 times 4 plus 4 times 3. That's for the first part, and then we multiply by this for the other part. 2 times 2 plus 1 times 1 plus 4 times 2. Now, to prevent confusion, I'm going to put these in brackets. Alright. Okay, so put them in their brackets. Alright. For the bottom part, the first row, the second row is 3, 1, and 2. And we're multiplying by the first column here. So we'll be having 3 times 1 plus 1 times 4 plus 2 times 3. And then lastly on that, we have 3 times 2. Please take note there's a space, there's a gap here. There's a gap there. We have 3 times 2 plus 1 times 1 plus 2 times 2. So this is going to produce 2 times 1, 2 plus 1 times 4, 4 plus 4 times 3, 12. And then the other part, the other side is 2 times 2, 4 plus 1 times 1, 1 plus 4 times 2, 8. And then we have 3 times 1, 3 plus 1 times 4, which is 4 plus 2 times 3, which is 6. Lastly, we have 3 times 2, which is 6 plus 1 times 1, which is 1 plus 2 times 2, which is 4. So this is going to give us 2 plus 4, 6. 6 plus 12 is 18. 4 plus 1, 5. 5 plus 8 is 13. 3 plus 4 is 7. 7 plus 6 is 13 also. And then 6 plus 1 is 7. 7 plus 4 is 11. So as I said before, when you're multiplying a 2 by 3 matrix by a 3 by 2 matrix, is going to produce a 2 by 2 matrix. So it's like you're removing these 3 and then we are left with 2 by 2. So take note, we can multiply a 2 by 3 matrix and then multiply it with a 3 by 2 matrix. We can multiply a 3 by 2 matrix by a 2 by 3 matrix. We can multiply 3 by 3 by 3 by 3 and so on and so forth. So you cannot multiply a 2 by 3 matrix by a 3 by 3 matrix. All right, that will not be possible. So as I said before, that's how we do addition, subtraction, and multiplication of matrices. That'll be all for today. Bye bye.